Hello and welcome to Math with Harrison. This is acceleration and speed. So, what we're going to go over in acceleration and speed is what's listed here, velocity. We're going to go over velocity, acceleration, and speed, and how they relate to each other. So as you can see in this definition, the velocity is the speed of something in a given direction. So what that means is kind of like speed, it's how fast something is going. But what the difference is between velocity and speed is that velocity has direction, which is underlined here. What that means is that it could be positive and or negative, not and or, it could be positive or negative at one time. Which means that it could be going negative 10 miles per hour or positive 10 miles per hour. And what the difference is between the positive and the negative 10 is that let's say you're starting at a point 0. And let's say east is the positive direction and west is the negative direction. If you're going east, then let's say 10 miles per hour, you would be going east at 10 miles per hour. But if you go west at 10 miles per hour, it would be negative 10 miles per hour because it's in the west or negative direction. The key word with velocity is direction. The next is speed. As you probably know, speed is how fast something is going. In this case, it doesn't have direction. Actually, in all cases, speed does not have direction. So to make that clear, speed has no positive or negative, it's only positive. So if you're going west, your speed can be 10 miles per hour, not negative 10 miles per hour. So that's the difference between velocity and speed. So again, it's really important that you understand that velocity is direction and speed is not direction. So, acceleration is, now we're going on to acceleration. Acceleration is the rate at which the velocity is changing. So basically how you relate acceleration and velocity is acceleration kind of like how velocity is a rate for how the position is changing. Acceleration is the rate for how much the velocity is changing. So velocity would be miles per hour. Acceleration would be miles per hour squared, or in this case, as I wrote, minutes per second squared. So, next, we're just going to relate acceleration and velocity. Right here, I am drawing the velocity versus time graph. And as you can see, it is a linear line with a slope of 2. The slope in this case is very, very, very important when you're relating acceleration and velocity because, as I wrote, acceleration is the derivative of velocity. Just how you've learned that velocity is the derivative of a position graph, because velocity is the rate at which the position is changing, the acceleration is the derivative of the velocity graph, just how it's the rate that the velocity is changing. So in this case, since it is a linear line, you take the slope of that line, and that is how the acceleration is changing over time. Because the velocity is increasing linearly, it is a constant change. It is a constant rate that the velocity is changing, which means the acceleration will always be 2. That is really important to understand because if you were to draw an acceleration versus time graph, the same graph, the same circumstance, one velocity, one acceleration, the acceleration graph would be a straight horizontal line. So that is pretty easy to go over right now. And now we're going to go on to the next topic. Just how you learned how velocity is the darn, I messed up. Sorry, got that quick little thing wrong. So just how an acceleration graph, if you want to find the velocity from an acceleration graph, at a certain given point, you take the area under that acceleration curve. You would take... Oh, messed up again. Third time's the charm, right? Alright, so, let me try this one more time. with position and velocity, if you want to relate the two, then under a velocity graph, if you want to find the position at a certain point on a velocity graph, you take the area under that graph at that given point. So, it's the same thing when you're relating velocity and acceleration. If you want to find the velocity at a given point from an acceleration graph, you just take the area under the acceleration curve at that given point, as I've shown in the graph that's being drawn right now. On the velocity versus time graph, which is on the left, the velocity at t equals 3 is 6. If you want to find that same velocity from this acceleration graph, you take the area under the graph at t equals 3. So, because the area under that graph at t equals 3 is 6, it shows that the area on an acceleration graph is the velocity at that given point. As you can see, 3 times 2 equals 6. So, next topic. You can use the acceleration and velocity to find speed. Just a quick hint on speed, if you didn't realize already, speed is the absolute value of velocity because it is always positive. So as I said a second ago, you can use acceleration and velocity to figure out if the speed of something is increasing or decreasing at a given point. So, there's a simple table that you can use to find if the speed is increasing or decreasing at a point, and I'm writing it right here. So, at a given point, to find if the speed is increasing or decreasing, all you need to do is find the velocity and the acceleration. As you can see, if at that given point the velocity and the acceleration is both positive, then the speed is positive. If the velocity is negative and the acceleration is positive, then the speed is decreasing. If the velocity is positive or increasing and the acceleration is negative, then the speed is decreasing. And if the velocity and acceleration are both decreasing or negative, then the speed is increasing. This is really important to know with different problems. It'll ask you 1,000 times to find the speed. All you need to do is use the velocity and acceleration and then just use this simple table and you will find the answer very easily. So we're just going to do a quick example problem, very simple, just to make sure that you understand it. So, this is the problem. If the velocity is increasing and acceleration is decreasing, is the speed increasing or decreasing? So just as I said, the speed is decreasing because if you use the table here, the speed is decreasing because if you use the table, you just find where the acceleration is decreasing, which is in the second and third row, and where the velocity is increasing, which is in the third row, and you line it up with the speed, it is decreasing. We're just going to do another final problem to culminate everything, make sure that everything is understood easily. So, there's a table here that I've given you, and what I want you to do is, using your knowledge of acceleration and velocity, use the table above to find if the speed is increasing or decreasing from t equals 4 to t equals 8. So, first, let's find the velocity. Well, since it's a velocity table, then from t equals 4 to t equals 8, which is from negative 5 to 10, the velocity is increasing. And now for more math, what we need to do is find the acceleration. As we said before, acceleration is the derivative of velocity, or the rate at which the velocity is changing. So all you need to do is find the derivative, find the slope of that interval. So what you do is find v of 8 minus v of 4, which is just, and divide it by 8 minus 4, just a simple slope formula. And what you get is 15 over 4, which shows that the acceleration is positive and increasing. So you line up a positive velocity and a positive acceleration, and what you get is a positive slope. As I said, 15 over 4 is positive and velocity is increasing, so you use the table to line it up. Speed is increasing. So we're just going to recap everything we learned today just to make sure that it's in your head and in simple terms. So quickly, velocity, what is very important is velocity is a rate, but more importantly, it uses direction. It can be positive and it can be negative. That is super duper important as you go ahead, because in different problems it'll ask you speed, it'll ask you velocity, and you need to know the difference between the two to give a correct answer. Speed has no direction, as I said before, and acceleration is the rate at which the velocity is changing. So it's just the derivative of velocity, just how velocity is the derivative of the position graph.
Wait, Harrison, how do you delete the recording or record over it?
Sorry students, somebody's asking me a question. So as I was saying, to make sure that acceleration, you need to know is the rate at which the velocity is changing. It is the derivative of the velocity. So there you go. I hope the rate at which you crap. Why did it override itself? I'm going to try this joke one more time. I hope this lesson helps you accelerate through the rest of math. There you go. Goodbye.